So in this video, what we're going to do is we're going to talk about z-score in the imperial rule. And in particular in this case, we're going to talk about Chifaru. She's curious about how her SAT scored compared with other students nationwide. So she knows that her score was 590. And in looking up at the website, she knows that in 2006, that's when she took the test, the mean score on the math section was 510, and they had a standard deviation of 103. And furthermore, the SAT math scores were mound-shaped, and thus they're approximately normal. And so in this case, the empirical rule will apply. All right, so let's remember what the empirical rule is. It says that we have this mean in the middle, and then if we look between one standard deviation above the mean and one standard deviation below the mean, there's going to be 68% of the data. Between two standard deviations above and two standard deviations below, in this region, we're going to have 95% of the data, and between three standard deviations below the mean and three standard deviations above the mean, we're going to capture almost all of the data, right? There's just going to be a few data points way out on the other wings. So for the SAT math score, our mean score was 510, and our standard deviation was 103 points. So this difference is going to be 103. So 103 plus 510 is 613, 103 more than that is 716, then 819, etc. 103 points below 510 is 407, another 103 points below that is 304, another 103 points below that is 201. So this is the approximate shape of the SAT math scores. Chifaru's score here at 590 is right in between the mean and one standard deviation above the mean. So she's not quite all the way there. So what we want to do is we want to figure out some way of intelligently placing her score somewhere in this mound of data. Since the empirical rule applies and the standard deviations say an awful lot about where data points are, is we can simply find out how many standard deviations away from the mean her score is. We call this number the z-score for the data point. And it's calculated by taking the data value minus the mean, and then we take that result and divide by the standard deviation. So why don't you figure out what Chifaru's math score, z-score is. Hit pause, do the calculation, and I'll show you what I got next. All right, so Chifaru's math SAT z-score, she got 590. The mean was 510. The standard deviation was 103. 590 minus 510 is 80. 80 divided by 103 is 0.7767. After we say something about probability, we'll be able to actually say quite a bit more about where this score sits in terms of all of the other math SAT scores. But until we get there, all right, let's stick with this calculation. We find the z-score if our data is mound-shaped.